Hello, we're getting ready for quiz 2 today. Going to go over some of our logarithm and exponential growth and decay function material. Just a few things to take a peek at here at the start. Okay, first we've got a logarithm and we're wanting to figure out what the x-intercept is in the domain and range. Now remember, when we're doing logarithms, I can look at a picture, but before I ever do, there should be a couple of things I just know off the top of my head. One of which is, when I have a logarithm, my range is always going to be infinite, negative infinity to infinity. And if I have a shift that moves left or right, do I here? Yeah. I've got a right 4 shift, which means my domain moves right along with it. Now, if I'd have had a left shift, my domain would have shifted into the negative. So, at this point, I go, okay, get this up. If I want to take a peek, or maybe I wasn't sure on one of those first two answers, so I want to take a little closer of a look. Okay, once I see my graph, I can notice, oh, it starts out here at 4. I could even look at my chart. 4 is where my last error is. So again, my graph starts here. You're like, well, 4 is error, why is that? Remember, that's where my asymptote's at. The parenthesis tells me it goes right up to 4 but doesn't cross it. So that's how I know where that's going to be. So my x-intercept then, I happen to get fortunate this time, because again, my x-intercept would be when y equals 0 is at 5, 0. Well, what if I didn't see that? What if I didn't see a 0 over in the y column? How could I do it? Again, look at your graph, and what you can do is you can hit trace, and you can say, well, I want to know, well, no, that's not going to help me with the y-intercept. Scratch that. Instead, what I would do is I'd use my 0, because that's the x-intercept. Oh, boy. And I'd start to look, and we've talked before about needing to be able to trap my intercept in. Now, notice I still don't have a y value because it's not defined until I get to 4. Now my y value is negative. I can go ahead and hit enter. My right bound, my y has to be positive because I'm trapping a point between negative and positive. Once I find that positive y value, I'll just hit enter twice and I can find it that way. Okay, make sure we keep those straight. X-intercepts, we're going to use the 0 function. Okay, rewrite into either logarithmic or exponential, the opposite of the one that it is. Here it's in logarithmic. Okay, I don't want to know 2 to what power is 64. Don't just write 6. I want you to know that this is base exponent solution. That's what I'm looking for. Again, here I'm not looking for you to tell me that this equals 343. That's not what I'm looking for. I'm looking, can you figure out base exponent, exponent, you see where the exponent is, Harty, solution, base exponent solution, base exponent solution. And sometimes you'll even have this first one to kind of look at. You can kind of cheat off of it if you need to. But again, that's what we're looking for there. Okay, evaluate. Now I know some of you are going straight to change a base. But again, I'd like you to try and think about this at least a little bit. So you'd kind of ask yourself, hey, 4 to what power is 16? That's what this is really asking me. This to what power equals this? Well, 4 squared. Okay. 3 to what power is 81? Now again, if you don't know, you can use change of base. You could do log 81 divided by log 3. That would work. But 3 to the 4th power is 81. Sometimes it's easier to just play with the numbers for a minute. Now here again, be careful on this one. 2 to what power is 1/4? And we talked about this some. We said, okay, I know going from a whole number to a fraction, it's going to be negative because I have to flip it. 2 to what power is 4? 2. Okay? We don't have to go to the calculator for everything. Use your brain a little bit. 9 to what power equals 1? Anything to what power equals 1? Anything to the 0 power equals 1. Okay. So again, try to use your brain as much as you can there. Okay. Find the inverse. Again, inverse, we switch the x and y. And then we work on solving for y. How do I get rid of log base 5? What's its inverse? We kind of made a joke of this. No, I'm not going to exfoliate both sides, even though I'd like my skin to look nice. No, we're going to exponentiate both sides. Cancel those guys out. Y equals 5 to the x. Not 5 times x, 5 to the x power. That's it. Expand the expression. Multiply becomes add. Divide becomes subtract. Exponents become coefficients. So let's take a peek. Multiply, multiply. Log of 2, excuse me, plus log of w plus log of z. Each multiplication dot gets replaced with an add. There's no exponents, there's no division. I'm fully expanded. Here I look and I've got, multiplication. Log 5 plus log m. And division is subtraction. Log p. Now somebody may ask at this point, and they look at that and they go, okay, we've talked before, sometimes we need parentheses around things to make sure things get sectioned off correctly. In this case, I don't need them because I always work left to right, so I'd see it's the multiply first, get these together, and then divide. But if you want to play it safe, you also could put parentheses around those first two just to be in good habit. But again, they're not necessary this time. So I get to my next part. Okay, again, multiplication and division are what we do first. We do with these, we do the exponents last. So I've got the natural log of x to the negative second. So multiplying, it's plus natural log of y to the third. And I'm dividing. So natural log of, w to the fourth. So at this point now, any of those exponents are all going to come down and become coefficients. Negative 2 natural log of x, plus 3 natural log of y, minus 4 natural log of w. And again, if you wanted to put parentheses around that first pair, you could, but again, unless those were down below, because then I'd have to make sure I got my correct order in, I don't have to do that. Condense the expression. Okay, everything goes the opposite now. Before we did exponents last, now we do exponents first and the other parts last. So if you have coefficients, get those back into exponents first. And now that we're going backwards, add goes back to multiply. 4 times y squared. Okay. I don't want the logs separated. I'm going to condense them into one single term. So that's what that would look like. Next one. Swing those coefficients back into exponents first. Minus becomes division. One fraction, one term, one single logarithm is what we're attempting to find here. Condense exponents first. And again, if you're comfortable as you're moving the exponents, simplifying them right away when you can, that's fine. 4 to the 1/2 would be 2. 2 to the 5th would be 32. And then when I go to finish, left to right, 2 times 32 is 64. And I'm dividing, since that's what subtract means, by 7. Leaving it as a fraction, probably your best route to go there. 15. Now this got some of you when we did the last quiz, so hopefully you catch it this time. When looking at the function f of x equals 16 times 1/4 to the negative x as it grows through decay, don't just look at the b. Be careful careful. That's a negative x. Okay. So you're like, okay, so I know since it's a negative x and that was going to be decay before, now it's growth. Good. Explain. It's not just, it's a negative exponent. Because if I had 4 to the negative x, that would be decay. So I can't do it that way. What does the negative exponent do? Well, the negative exponent causes my v value to flip. Or you could say, make it a reciprocal. You even could say the negative exponent causes this and literally show me what happens. Because now you can say, oh, when the b value is 4, that would be growth. And that's what that negative exponent makes my 1/4 treat like. You can't just say it's a negative exponent. That will not work. Okay, so be specific. Graphing these guys. Again, reminders. When we're doing growth and decay, different from the logarithms, so be careful. When we're doing growth and decay, my domain is going to be negative infinity to infinity. My range is going to move in coordination with my up or down shift, if there is one. This one moved down 4. That's what my range is going to do. So I look and I go, okay, I need some points, though, to work with. So we'll go ahead. Again, I don't want the x minus 4 in parentheses because that would mean I'd be putting it up here in the exponent. I want it down here. So look at my graph. It shifted down 4. That looks good. And I just want to get some points. Sometimes you'll be able to get some whole numbers. Sometimes you won't. It just depends. So again, just get enough, A, that you can make a pretty accurate graph. I don't want this to be a complete slop fest of, oh, I'll just kind of half-heartedly do this. But here's what I am going to be watching for. See that range starting at -4? When I look at your graph, it better not be going past that value. If you get sloppy and it ends up down here in 6 or 7, I'm going to mark it wrong. Okay, so you have to know there's a connection between your range and where this value starts to tail off and curve. If you pay no attention, yee. 17, again with the logarithms, we've got our base points, but again, what are my shifts before I start? Let's see here. I'm going to go right 2, and I'm going to go up 1. Now, can I just plug this into the calculator? Sure, but remember we talked before about having base points and shifting them. My 2 base points typically on these would be at 1, 0 and 10, 1, but then I'd do these shifts. So if I go that route, moving right 2 would be adding 2 to each of my x values. And up 1 would add 1 to each of my y's. Now again, if you're not comfortable for some reason with that, and I'd hope that you would be, but if not, you do always have the option of just going in, typing it into the calculator. There's my 3, 1. There's my 12, 2. So I think 3, 1. A little off the chart here. 12, 2. And again, logarithms. Now, does that just stop like that? Is it going to look like a square root function? Well, Harty, it's what the picture looks like. Remember, though, there's an asymptote here that is giving me some of that issue. So when I get to 3, 1, it doesn't mean that my graph stops there. Remember, when we're doing logs, my range goes this way, but this is just telling me I shifted my domain right 2. this is going to keep coming down. You're like, well, how do I know that? Because I look at it, looks like it's just done. Again, if you wanted to, and you don't have to, but if you changed your table set, instead of going to ones, like let's say you changed it to hundredths, and you started to look, I probably should have started a little closer to the value I wanted, shouldn't I? Yeah, let's change that. Because I want you to actually see how this works. All right, let's try this again. Because I just want you to be able to see it so you trust me here. I don't expect you're going to have to do this on your own when you're doing it. But notice how there, now you can start to see there's values going here until I get really close to 2, and then that's when it goes away. So you can see that the values are actually going to keep going downward there. But again, I wouldn't go to the time of changing my table sets for those because that could get kind of time consuming. Okay, to the back. Now we start getting into some other issues. All right, if f of x is 6, g of x is 6 to the x plus 2 minus 4, explain how to obtain g of x from f of x. What are the transformations? What are the two shifts? That's all I want to know. Left 2, opposite of what you think. Down 4. So let's see here. Scientist, we've got a specimen that begins with 1,000 bacteria. There's my A value. If the specimen grows by 12% per minute, remember, do it as a decimal. Write an equation that represents the bacteria's growth. Then calculate how many minutes will pass before the population reaches 1,800. The formula is there. The only thing you've got to figure out is if it's plus or minus, and growth, well, that's probably going to be plus. So 1. Okay, that's my general form. When will the population reach 1,800? Let the calculator do the heavy lifting. Type in your expression. Look at your chart. And again, when is it going to reach 1,800? Somewhere between 5 and 6 years. Keep life simple. Okay? 20. You're going to invest your birthday money in an account paying 3% interest compounded monthly. Compounded. So we see our equation here. Monthly. How many times does a month happen in a year? 12. Use your calculator's function to determine how long it will take for your money to double. You're like, wait a minute, they didn't tell me how much money I have. I know how much interest. I know my N. I don't know P. You get to create however much birthday money you want. If you want to be a millionaire at your birthday, you go for it. I just use 1,000 on everything, even though I never got $1,000 for a birthday, but that's a different story for a different time. So 1,000, 1 plus my rate divided by N, and then I do N times T. How long? I don't know. That's what I'm trying to find out. How long will it take for my money to double? How long will it take for, in my case, it to get to 2,000? If you used 1,000,000, how long would it take to get to 2,000,000? If you used 100, how long would it take to get to 200? Now, I don't type the 2,000 into my calculator. That's just telling me the Y value that I'm looking for. So clear that out. So 1,000 plus my 3% divided by how often it's compounding. Got to remember the parentheses for your exponent, or this is all for naught. Okay, and again, we'll just use the X for that. And when's my money going to double? It's taking a while. Holy cow. Whew. Like 23 to 24 years. So for some of you, you're going to be celebrating your 40th birthday before that money doubles. I'd probably spend it before then, but that's me. But that's how I'd find that. And then finally, what we started to get into here towards the end. Okay, solve each equation for x. If necessary, round your answer to the nearest hundredth. Now here, could I do a logarithm? Sure. But let's think about this for a minute. Whole numbered exponent. I know it's negative, it's going to flip. 5 to what power is 25? Okay. 2. Keep life simple. Now, is it always going to be that easy? No. I get to 22. I'm like, oh, bases are different again. Do I have to do that big, huge, crazy log thing? No, you could, but here's a simpler way. Can I change these both into something where I have the same base? Well, let's see. 9 is actually 3 squared. Okay. Can I turn 27 into something with 3 as a base? I sure can. 3 cubed. Because now, again, once my bases are the same, I basically, oops, I didn't want to scribble my 2 out, are going to ignore them and just use the exponents that are left. Again, exponent rules, power to power, you're multiplying them. And then I'm just going to solve the equation I get. And it's okay to get fractions. That's not a bad thing. But again, keep using the skills that you've gotten as you kind of played with these some. Again, some of you may look and go, okay, I'm going to exponentiate. I want to get rid of the log. Okay. 64 equals 2 to the x. Okay, 2 to what power is 64? Play a little bit. Might be surprised that it's really not a hard number to figure out. You're like, well, could I just change a base? Could I do log of 64 divided by log of 2? Certainly could. Certainly could. So look at this last one, like, ooh, that's kind of weird. Base, exponent, answer. Oh. Well, all right, so I take the square root, and it's plus or minus 7. Not so fast. Remember what we've talked about when we've been talking about logarithms. Let's test out this negative and see how this works out for us. So if I do change a base, I'd have a log of 49 divided by the log of negative 7. Yeah, can't do that. Can't take the logs of the negative numbers. So do not give me the negative. Be careful. Okay. Evaluate. Here's a couple of gimmies. Log base 2 and 2 are inverses. I'll take the 9. 8 and log base 8 are inverses. I'll take what's left. You wish there were more of those on there, don't you? And then finally, and I wasn't mean down here either, okay, solve for x by showing work, check your answers. Again, you know what we're checking for. These have the same log with the same base. That's nice. Because now all I got to do is set what's in the parentheses equal to each other. And yes, it is okay if you get a fraction / decimal for an answer. Just make sure, you're like, what is 13 divided by 3? I don't know that off the top of my head. If you don't, kind of get yourself an idea, because you want to make sure you're not getting a negative logarithm. Okay, 48 minus 8 times a little over 4, that's still going to be positive. 4 times 4, yeah, that's okay. We're good. Okay, that's all I'm checking for, is make sure I'm not getting a negative logarithm. Dang, nice again on number 27. I can't believe I was this nice. X squared plus 2x equals 4x plus 15. Okay, x squared, that's where it's going on. Yes, it's Algebra 2 F word time. It is time to factor everything to the x squared side. We're hoping that it's factorable. If it's not, we may have to use the quadratic formula here. Let's see. Negative and a positive. Negative's bigger. 5 and 3. X equals 5. X equals negative 3. Before you circle, make sure. The 5, I'm sure on that one. Negative 3 squared is 9. 9 minus 6 is still positive. That's good. 4 times negative 3 is negative 12, plus 15 is still positive. Okay, they're both good. Again, make sure that you've got this stuff down. You know me at this point. This basically is the quiz. I'm going to change some numbers. You've had a lot of homework this time. Make sure it's done. That's good practice to go back through this again. There's copies of this available online. Watch the video again. Watch a lesson. Have the homework done. Be ready, because this is the last one before progress reports. Good luck.